Hello, this is Kerry of Kerry Optical Systems. This is an instructional video on the operation of the split path point diffraction interferometer, or SPPDI, available from Kerry Optical Systems LLC. This video focuses on the setup and use of the Educator demonstration package, but the procedures described here are generally useful for any interferometric setup which uses the SPPDI. The Educator demonstration package is small and lightweight and can be easily set up on a desktop. Several major components are included with the Educator demonstration package. These include the SPPDI, a 1-inch diameter concave spherical reference mirror, which is held or mounted in a precision adjustable 5-axis mirror mount, a 6-inch wide by 12-inch long by 1/2-inch thick aluminum base plate with 1/4 threaded holes on 1-inch centers, 2 1-inch diameter mounting posts, and 2 clamps, which are used to clamp the mounting post to the base plate. The clamps are attached to the base plate by means of 1/4 stainless steel socket head cap screws. Use of these clamps allows for a quick and easy adjustment of the position and orientation of the SPPDI and test mirror on the base plate. The lengths of the 1-inch diameter mounting posts were chosen to provide for a 3.5-inch height of the SPPDI and test object above the base plate, or for a height of 4 inches above the surrounding desktop. In the Educator demonstration package, the test object consists of a 1-inch diameter by 100 millimeter focal length concave spherical mirror. The radius of curvature of this mirror is 200 millimeters. When this mirror is placed correctly on the base plate, the mirror will be 200 millimeters from the 5-micron pinhole aperture located within the SPPDI enclosure. The virtual position of the SPPDI pinhole aperture lies 32.5 millimeters inside the front face of the SPPDI enclosure. So in this demonstration package, the mirror will be located about 167.5 millimeters from the front face of the SPPDI enclosure. The Educator demonstration package is shipped in a pre-assembled configuration. However, this instructional video will also include a description of the process used during assembly of the demonstration package. The SPPDI is attached to the shorter 1-inch diameter mounting post. The mounting post is then attached near the center line of the base plate, near one end of the base plate. The SPPDI laser is connected to mains power via the included 3.2 volt DC laser power supply. The orientation of the SPPDI on the base plate is adjusted so as to direct the expanding laser output beam down the center line of the base plate. The position and orientation of the SPPDI is then fixed to the base plate by tightening the mounting post clamp. The included concave test mirror is inserted into the 1-inch diameter mirror cell of the 5-axis mirror mount, and the set screw which retains the mirror is lightly tightened. Over-tightening the set screw will deform the shape of the mirror, which can be easily observed in interferograms of the mirror. After the mirror is installed, the adjustable mirror mount is attached to the longer mounting post, and the mounting post is attached to the base plate in such a way as to center the mirror within the footprint of the expanding beam produced by the SPPDI. The position and orientation of the mirror is then fixed to the base plate by tightening the mounting post clamp. Final focusing and alignment of the test mirror is accomplished by means of the 3 precision micrometer screws found on the mirror mount. Observation of the position of the beam reflected by the test mirror will be aided by use of a white business card with a 1/4-inch diameter hole punched near one end. This business card is placed over the beam exiting the SPPDI. The return beam from the test mirror can then be observed, and the position of the mirror adjusted with the precision micrometer screws. If the return beam significantly overfills or underfills the 1/4-inch hole, it will be necessary to adjust the distance of the test mirror from the SPPDI so that the return beam is about the same diameter as the hole. When the beam returned from the test mirror is centered over the 1/4-inch hole, it will be possible to begin observing interference fringes. The included alignment camera power cable is connected to the user-provided 12-volt DC 500 milliamp power supply. This power supply output power cable should be terminated with a standard center positive 5.5 mm by 2.1 mm male barrel connector. After the barrel connector is connected to the input power connector of the video camera and power is applied, the AV signal from the camera may be connected to and viewed on any display monitor or TV that provides an AV type input. After the video camera power and signal cables have been connected and power has been applied to the SPPDI laser, it should be possible to observe the SPPDI pinhole aperture and 4 surrounding linear fiducial marks on the video display. The rotational orientation of SPPDI polarizer adjustment handle number 2 adjacent to the SPPDI alignment camera fixture should be adjusted to maximize the intensity of the image of the pinhole aperture and fiducial marks on the display screen. Polarizer number 1 should be rotated into the beam blocking position via polarizer handle number 1 in order to more clearly observe the pinhole aperture and fiducial marks. After polarizer handle number 1 has been rotated into the beam blocking position, it should be possible to observe the point spread function of the incoming test mirror signal beam on the AV display monitor. This is possible because some light leaks through the partially transparent pinhole aperture plate. The size of the point spread function will be an indication of how far the test mirror is from best focus. In order to improve the focus of the point spread function and thereby reduce the size of the point spread function, the 3 micrometer screw adjusters on the mirror mount must be adjusted sequentially in the same direction, either clockwise or counterclockwise. This has the effect of changing the distance of the test mirror from the SPPDI. When the point spread function is small and precisely centered on the pinhole aperture, the amount of light passing through the pinhole aperture will be maximized. The light which passes through the pinhole aperture will diverge in a pure spherical wavefront, which constitutes the SPPDI internal reference beam. The reference beam will be mixed with the unmodified signal beam, which passes through the SPPDI, thus giving rise to interference fringes, which indicate the shape of the test mirror. When the intensity of the reference beam has been maximized, polarizer number 1 may be rotated away from the beam blocking position and the signal beam adjusted for proper intensity. When the intensity of the signal beam and reference beam are approximately equal across the aperture of the test mirror, high contrast interference fringes will be observed with a digital camera. It will be necessary to assure that the image of the test article produced by the digital camera lens is focused on the test article, and that the image of the test article is not vignetted by the aperture setting of the camera lens. For example, in the case of the 1-inch diameter test mirror supplied with the Educator package, an F8 diverging beam will appear to diverge from within the body of the SPPDI enclosure. It is necessary to intercept this beam before the beam grows too large by placing the digital camera lens as close as possible to the exit port of the SPPDI enclosure. This necessitates the use of a camera lens with a maximum aperture stop of at least f2.8 or faster. The ISO and camera shutter speed settings may then be adjusted to produce interference fringes and interferograms which are not over or underexposed. When high contrast fringes are observed with the digital camera, the camera image may be relayed to a large format screen. An interferogram may be taken with the camera and analyzed with interference fringe processing software, such as with the excellent DFT Fringe computer program produced by Dale Eason and available for free download. This concludes the video tutorial for the Carry Optical Systems SPPDI Educator Demonstration Package. For more information, contact Carry Optical Systems on the internet at www.carryos.com, or you can reach us via email at info@kerryos.com.